Hello viewers, welcome to today's lecture on cellular telephone systems. In the last lecture, we have discussed how wireless LAN can be used to communicate over a small geographic area. In today's lecture, we shall see how wireless communication can be used to cover a large geographic area. And here is the outline of today's lecture. First, I shall give an overview of cellular telephone systems. Then there are several important concepts that are being used in cellular telephone systems. First one is the frequency reuse concept. I shall discuss about it, which is very important for efficient utilization of channels in cellular telephone system. Then there are several other concepts like mobility management, handoff management and location management. Because of the mobile, because the users are now moving from one place to another, as a consequence you require these features. Then I shall discuss about several practical systems. First one is the first generation cellular network AMS, which was developed in North America based on analog technique. Then there are several second generation cellular network like DAMS, GSM and CDMA. We shall discuss about them in details. Then finally, I shall discuss about the goals of third generation cellular networks, and this third generation cellular networks are still under development and also being deployed in some places. So, on completion of this lecture, the students will be able to explain the operation of cellular telephone networks, how telephone networks works and the various other features of it they will be able to explain. Then they will be able to explain the operation of the first generation cellular telephone network based on analog technique, that is your AMS, advanced mobile phone system. Then they will be able to distinguish between first generation and second generation cellular networks. Second generation cellular networks are essentially developed for digital technique compared to, in contrast to the analog technique used in the first generation AMS network. Then they will be able to explain the operation of the second generation cellular networks, the three types that I have mentioned, they will be able to explain. Then they will be able to state the goals of third generation cellular networks. First, let us try to give the motivation behind cellular telephony. It is essentially a system level concept which replaces the single high power transmitter with a large number of low power transmitter. Conventionally, a very high power transmitter is used when somebody wants to cover, when a large geographic area is to be covered, but this concept is not used in cellular telephony or cellular telephone networks. What is being done? A large number of low power transmitters are being used to cover a large geographic area. That is one important difference between the conventional approach and the cellular telephone approach. And here the goal is to provide wireless communication between two moving devices. The moving devices are essentially mobile stations or handsets, or between one mobile unit and a stationary unit, usually referred to as landline. So, communication between two mobile stations or between a mobile station and a stationary station ought to be provided. And of course, as I said, the another important goal is to accommodate a large number of users over a large geographic area. You look at the 2 points. First one is the large number of users, where you will see which will be possible because of frequency reuse, which we shall discuss, and over a large geographic area. So, 2 are the important objectives to be satisfied. And as I mentioned, it uses a large number of low power wireless transmitters to create cells. Cells are small area varying from 10 to 20 kilometer across, as we shall see. Then the power level of the transmitters, both of the transmitters and the handsets are variable. to allow cells to be sized according to the subscriber density. That means, the geographic area to be covered under a transmitter is no longer fixed, it is variable, and how it can be done we shall discuss. And subscriber density and demand within a particular region. Then as mobile users travel from cell to cell, their conversations are handed off. That means, when a user or a mobile station moves from one place to another, it is very common that they will move away from a particular cell and go to another new cell. So, it has to be done in a seamless manner, and the approach to be used to satisfy seamless transfer is known as handoff. So, the conversations are to be handed off between cells. Then the channels are used in one cell, channels used in one cell be reused in another cell some distance away. As I mentioned, this concept of reuse of cell frequencies channels leads to a higher capacity of cellular telephone network. So, let us have a look at the simplified structure of a cellular system. It comprises the following components: mobile station, large number of mobile stations which are essentially mobile handsets which are used by an user to communicate with each other, and cell is a service area each cellular service area is divided into small regions called cell. So, it can be 5 to 20 kilometer across, and there is a base station, and each base station contains an antenna which is controlled by a small office. And in addition to that, there is a mobile switching center where each base station is controlled by a switching office called mobile switching center. It will be clear from the next diagram. So, here we see you have got a number of cells. Here you see this honeycomb like cells are shown here. In reality, it will be circular, but for the purpose of modeling, this honeycomb like cells are convenient to model. So, you see you have got a transmitter. Apart from this transmitter, there is a computer which controls this transmitter. So, in each cell you have got a transmitter and a computer which controls the transmitter, and you have got a number of mobile stations, as you can see, and a number of such cells are controlled by a single mobile switching center which can be considered as an end office in a public switch telephone network. And this in turn is connected to the public switch telephone network, so that the mobile stations can communicate through the base station and the mobile switching center and the public switch telephone network to any stationary phone or landline phone, as I mentioned. So, these are the stationary phones, landline phones, and these are the mobile phones. So, this is the overall structure of the system. Now, let us look at the concept of frequency reuse, which is very important from the viewpoint of the channel capacity. So, the cellular systems rely on an intelligent allocation and reuse of channels. So, each base station is given a group of radio channels to be used within a cell, and base stations in referring cells are assigned completely different set of channel frequencies. That means, what is being done here, this is being explained, this frequency reuse concept is explained here. For examples, cells with this is a cluster. This cluster is the area over which all the frequency channels are being available. That means, n cells which are collectively use the available frequencies is called a cluster. So, let us assume S is the total number of channels available. So, which is being divided among n cells. In this particular case, n is equal to 4. So, A, B, C, D, that means each of these cells will get 1/4 of the channels available. That means, S by K is the number of channels that can be used in each of these cells. Now, as you can see here, this A has appeared here. So, A has appeared here, A has appeared here. So, A has appeared twice. That means, same set of frequencies are to be used in these three cells. Similarly, same set of frequencies to be used in cells B, cell B and cell B. So, in all these three cells, same set of frequencies will be used. So, this is the frequency reuse concept. So, but at one point you must notice that B's or A's are, for example, 2 A are separated by in this particular case at least by one cell. So, if you have larger number of cells, 2 reusing cells will be separated by several such cells. That means, the transmitter as well as the transmitter power will be restricted such that the signal does not reach another cell reusing the same set of frequencies. So, the reuse factor is used, which is essentially the fraction of total available channels assigned to each cell within a cluster, which is equal to 1 by n. As I said, S this fact S, if S is the total number of channels, then the total number of the number of channels to be available in a particular cell will be equal to S by n, that is equal to K. K is equal to S by n. So, reuse factor will be 1 by n. So, in this particular case, the reuse factor is 1 by 4. Now, as I mentioned, by limiting the coverage area called footprints within the cell boundaries, the same set of channels may be used to cover different cells separated from one another by a distance large enough to keep interference level within tolerable limit, as I have explained with the help of this diagram. So, this is the frequency reuse concept which is used in cellular telephony, so that the channel capacity, total capacity is increased. For example, here the capacity is m into k into n. That means, if in a area, if it is replicated m times, total capacity is multiplied by m. So, you may have 100 or a particular set of frequencies may be replicated 100 or 1000 times, depending on the density and the number of users. That means, so you see the capacity is multiplied by m because of this reuse of reuse factor. Now, let us see how the frequency reuse is dynamically changed. For example, it is found that a particular area, maybe urban area, where the population density is very high, densely populated. In that case, the number of users is large. A particular cell is divided again into a number of smaller cells. So, micro cells you may call, and again you can reuse a number of the frequencies, several frequencies. So, you see which in an urban area, in a rural area where the number of users is sparse, then you can cover by using a single cell. Obviously, the both the transmitter of the base station as well as the mobile stations power will require larger power. On the other hand, here the communication is restricted over a small area, which is shown in the magnified here form here. So, this is for the densely populated area. So, in case of densely populated area, you will be using smaller cells. So, you will require lesser transmission power to cover. On the other hand, sparsely populated areas, you will be using larger size cells. That means, it will cover larger area. So, footprint will be bigger compared to this. So, in this way, in a dynamic manner, the cells can be of various size depending on the number of users and number of users or the population density. Now, let us see how exactly the transmission and reception take place. we are all familiar with cellular telephone nowadays. A caller enters a 10-digit code, which is essentially the phone number, and then presses the send button. The mobile station scans the band to select a free channel and sends a strong signal to send the number entered. So, mobile stations now does the transmission. The base station relays the number to mobile switching center. So, after receiving from the mobile station, the base station now relays it to the mobile switching center. The mobile switching center in turn dispatches the request to all the base stations in the cellular system. So, as I said, a mobile switching center may control a large number of base stations. So, it is broadcast over all the base stations. Then the mobile identification number is then broadcast over all the forward control channels throughout the cellular system, and this particular technique is known as paging. And the mobile station responds identifying itself, that means the destination mobile station responds by identifying itself over the reverse control channel. So, there are two different channels, forward channel and reverse channel, as we shall see, and the base station relays the acknowledgement sent by the mobile station and informs the mobile switching center about the handshake, and the mobile switching center assigns an unused voice channel to the call and call is established. So, this is the sequence of events that take place whenever a mobile station wants to transmit to another mobile station. Now, let us see what is the function of the mobile station which is receiving. So, in the receive mode, all, as you know, all the idle mobile stations continuously listens to the paging signal to detect messages directed at them. So, and when a call is placed to a mobile station, a packet is sent to the callee's home mobile switching center to find out where it is. A packet is sent to the base station in its current cell, which then sends a broadcast on the paging channel. The callee mobile station responds on the control channel. There are, as you shall see, the channel is divided into a number of data channels and control channels. So, this communication takes place over the control channel, and in response a voice channel is assigned and its ringing starts in the mobile station. That means, whenever a mobile station is in the receive mode, this sequence of event occurs and finally, ringing takes place in the mobile station, and a particular mobile station now can receive a call. So, this is how receiving takes place. Now, let us consider consider how the mobility of different stations are managed, and that concept is, that technique is known as mobility management. As we have already seen, a mobile station is assigned a home network, or over which it can roam around, and which is under the control of a mobile switching center, and it is usually called as the location area. And when a mobile station migrates out of the current base station into the footprint of another, a procedure is performed to maintain service continuity, and this is known as handoff management. How it is being done? An agent in the home network called home agent. So, it is some kind of software running, keeps track of the current location of the mobile station. The procedure to keep track of the user's current location is referred to as location management. Now, handoff management and location management, these two together are referred to as mobility management. Let us now see how the handoff management is performed, then we shall see how location management is performed. So, as we have seen, at any instant each mobile station is logically in a cell and under the control of cell's base station. Now, when a mobile station moves out of a cell, the base station notices mobile station signal fading away and requests the neighboring base station to report the strength they are receiving. The base station then transfers ownership to the cell, getting the strongest signal, and the mobile switching center changes the channel carrying the call. As we have seen, two adjacent cells do not use the same frequencies. That means, the same frequencies. As a consequence, when a particular mobile station moves from one base station to another base station, a different frequency channel is to be assigned, and that is the function of the handoff. And there are two handoff techniques commonly used. One is known as hard handoff and another is soft handoff. In case of hard handoff, a mobile station always communicates only with one base station. On the and whenever it moves out from one base station to another base station, first it terminates communication with the present base station, and then it starts communication with the next base station to which it is moving in. So, in this way there is a sharp transition which takes about 300 millisecond to take place. The transition will take about 300 millisecond. So, as a consequence, in case of hard handoff, the communication is with one base station, and as a mobile station moves, it changes from one base station to another base station, and frequencies also, the channel frequencies also change. On the other hand, in case of soft handoff, the base stations, a mobile station communicates with two base stations, two neighboring base stations, and as a consequence the base stations they can tell about the signal strengths, they can get in the base stations and mobile stations know about the strength of the signals both the stations are receiving. As a consequence, a mobile station keeps on talking with two neighboring stations. As it moves from one base station to another base stations, it is performed in a soft manner. That means, while communicating with two at a particular instant, it switches from one base station to another base station. So, that is why it is called soft handoff. That means, at a particular instant the communication is performed with two base stations. Now, let us focus on location management, and it requires two basic functions, two fundamental operations. One is known as location update, another is paging. So, when a mobile station enters a new location area, it performs a location updating procedure by making association between a foreign agent and the home agent. That means, the softwares which keeps track of that. So, foreign agent is essentially the software running in that host location area, I mean host area where it has moved, and home agent to which the mobile station belongs. So, one of the base stations in the newly visited location area is informed, and the home directory of the mobile station is updated with its current location. So, the home agent keeps track of it and it modifies the directory. And when a home agent receives a message destined for mobile station, it forwards the message to the mobile station via the foreign agents. That means, these two softwares running in two different systems communicate with each other to keep track of the mobile station. And of course, whenever it is being done, an authentication process is performed before forwarding a message for a mobile station. So, in this how in nutshell location management is performed. So, we have discussed about the basic operation of the basic operations and functions to be performed in mobile telephone networks, telephone systems. Now, let us look at the different implementations. First, we shall consider the first generation technique. In the first generation, that was mainly designed for voice communication, and although several systems were developed, the most popular is the advanced mobile phone system used in North America, that was developed by the Bell Labs, and which was in operation in North America. And AMS is a analog cellular telephone systems, as I have mentioned, and it uses 800 megahertz ISM band, which does not require any licensing. ISM stands for, as you already know, industry, scientific and medical band, which does not require any licensing, and two separate analog channels are used. One is known as forward, another is reverse analog channels. So, for duplex communication, two separate channels are necessary, and the band between 824 to 849 megahertz is used for reverse communication, that is from the mobile station to the base stations. On the other hand, the band between 869 to 894 megahertz is used for forward communication from base station to mobile station. Let us see pictorially how it occurs. So, you see these are the two separate bands. This is for forward communication, 869 to 894 band, which is used for forward communication, which is divided into 832 30 kilohertz channels. So, 832 30 kilohertz channels. So, you have got 832 distinct channels with different carrier frequencies, and similarly for reverse communication from the mobile station to the base stations, you have got again 832 frequency bands, each of 30 kilohertz. And of course, all of them are not used for data voice communication. As I mentioned, out of this 832, 42 are used for control. Another technique approach is used. Usually, each location area is divided into is shared by two service providers. That means, since two service providers are operating in the same area, that means the channels are also equally divided between them. And how? So, that means 832 is divided into 2. So, each of them have 416 channels available, out of which 21 are used for control and remaining are used for communication, voice communication. And it uses the FDMA technique. Let us see how it is being done. So, it uses frequency division multiple access to divide each 25 megahertz band into 30 kilohertz channels. So, you see so many analog channels are broadcasted simultaneously, and here each of the voice channel, 3 kilohertz voice channel is frequency modulated to generate 30 kilohertz analog signal, which is used for communications. So, you have got as we have seen, out of 832 voice channels, out of which of course, you have to subtract 42, that means 790 voice channels are there. So, 790 voice channels, each of 3 kilohertz, after frequency modulation you get 30 kilohertz. So, that 30 kilohertz channels, which are analog signals, are communicated between base stations and the handsets by using frequency division multiple access. So, you see these are essentially transmitted in parallel through air, and it goes to the from the mobile station, it goes to the mobile transmitter or receiver in the base station. Similarly, for the forward channel from the transmitter, instead of so many you will have the base stations, you have the transmitter of the base stations, from which the signals are transmitted by using different frequencies, and again 25 megahertz band is created. However, in that case the bandwidth is the frequency band is different. So, you can see two different frequency bands are used for communication in two directions. So, full duplex communication is performed between the mobile station using the base stations, and two-way communication is performed. So, two mobile stations are communicating with the through the base stations. Two mobile stations communicate each other through these base stations. And as you can see, in amps it uses frequency reuse factor of 1/7. So, this is one cluster, and the 400 that those frequency bands, that means 832 frequency bands are divided by 7, and each can be used in each of these cells. So, frequency reuse factor is 1/7. So, 832 by 7, that is the number of channels that is available in each of these cells. So, you have got 7 cells in a cluster. So, these are repeated in a honeycomb like fashion, that is why it is called cellular communication, because of this cellular network. That means same thing is repeated over and over. It is name has come from this honeycomb like structure. So, this is AMPS based on analog communication. Now, in case of second generation communication, it was based on digital technique. We have seen that AMPS uses analog communications, and it is very easy to tap, I mean eavesdropping, I mean it is very easy to perform eavesdropping, which is called eavesdropping. That means any receiver receiving a particular frequency, we have seen those frequencies, each will have a particular carrier frequency. If it tunes to that in the frequency FM band, it will be able to receive the voice, and that is how there is an interesting story that communication of that Princess Diana was recorded, although they were communicating using this cellular phone, and that led to some problem. Anyway, so this is not very private. Privacy is less. So, there is no privacy, you can say, because there is no encryption or any other technique that is being used. So, very easily one can hear the voice of other people's conversation. So, and also it is not very reliable. So, and not very high quality. So, in the second generation technique, it was developed to provide higher quality mobile voice communication, and it is mainly based on digital technique. Instead of using analog approach, there we have seen that the bandwidth of the voice is only 3 kilohertz, and that is being frequency modulated to generate 30 kilohertz. So, instead of that, here it is done in a digital manner instead of analog technique. So, there are 3 different approaches developed for that. First one is interim standard 136, which is also known as digital AMPS. So, AMPS is advanced mobile phone system used in North America in the analog form, and the digital version of it is known as interim standard 136, and it is based on TDMA and FDMA. And second technique is known as GSM, which was developed in Europe. Before the digital system came in Europe, many analog in different parts of Europe, in France, in UK, in other countries, different analog techniques were used. So, they wanted to use a common digital technique, and that common digital technique that emerged was given the name as GSM, which is based on again TDMA and FDMA. And another technique that was developed based on CDMA is known as interim standard 95, based on CDMA, FDMA. So, we shall discuss these 3 digital techniques one after the other. First, let us consider the DAMPS, which is essentially digital version of analog AMPS, and it is backward compatible with AMPS. By that I mean, if somebody is having the analog telephone and analog handset, and if somebody is having the digital handset, they can communicate with each other. So, that is why that is the basic objective of backward compatibility. And as a consequence, they had to use the same bands and same channels as it is used in AMPS. So, the bands and channels used are same, not different, and it also uses the same frequency reuse factor 1/7. So, except it is digital, rest of the thing is same as we see in terms of frequency reuse factor, in terms of frequency bands and channels, it is identical to amps to maintain frequency, to maintain backward compatibility. Now, here as we shall see how it is being made digital. We notice that here the 3 kilohertz voice is digitized using a very complex PCM and compression technique to generate 7.95 kilobits per second. If you perform simple digitization, obviously it will be at least say 3 into 3 kilohertz. So, you have to sample it at 6 kilohertz, then you have to multiply with say 6 bit or 8 bit, that means 6 into 8, 6 into 8 is 48 kilobits per second. But by use of suitable compression technique, the digital signal is having 7.95 kilobits per second. So, 3 such these digital channels are time division time division multiplexes. So, this multiplexing is performed in time division to generate of course, each of them is used, and then let me show you the next diagram to explain this. So, actually what is being done here, 25 frames are being sent, and each of 1994 bits divided into 6 slots, and these 6 slots are shared by 3 channels. That means, here you have got 6 slots, say 1, 2, 3, 1, 2, 3, that means 1, 2, 3, 1, 2, 3. So, this is one frame, and you have got 25 such frames per second, each of 1994 and bits, and each slot is having 320 bits, out of which only data is 159 bits, 64 control and 101 is used for error correction. So, in this way you have got this 48.6 kilobits, and that 48.6 kilobits is converted into analog form, analog signal, by using QPSK to generate 30 kilohertz analog signal, and that is being broadcast, that is being sent from the mobile station to the transmitter receiver of the base station, or from the base station transmitter receiver to the mobile station. So, this part, as you can see, is same as the analog amps, and this part is different, so that the digital technique is used. The second technique that is being used is known as GSM. As I mentioned, this GSM, which is meant for global system for mobile communication, that's an European standard to replace the first generation technology. The first generation technology that were used in different parts of Europe were different, but here it is combined to have a global system for mobile communication throughout Europe, and it is based on again for duplex communication, same set of type of concept as DMs, but the frequency bands are different. As you can see here, it is more towards 900 hertz than the earlier one was towards 800 megahertz. Here it is more closer to 900 megahertz. So, you see this is used for forward band from 935 to 960, each of 200 kilohertz. Similarly, from mobile station to base stations, you have got 890 to 950 kilohertz, and you have got each of you have got a number of 124 channels, each of 200 kilohertz. And how the different signals are generated is shown here. Each voice channel is digitized and compressed to generate 13 kilobits per second, and then 8 users can communicate using time division multiple access, and then they are converted, they are combined to form a multi-frame, as we shall see. So, this is coming from an user, this is your user data, and the user data plus user error control bits is 114 bits, and then you have got some control bits, these are added together to form a slot. And as you have seen, you have got 8 such slots, one first user, second user, 8th user. So, from 8 such slots data is coming, and these 8 slots form a frame, and 20 such frames form a multi-frame, and 26 out of which out of these 26 frames, 24 are used for traffic, that means for voice or data communication, and 2 are used for control, and this is repeated in 12820 millisecond. So, if you send this combine all these together. So, to send one multi-frame you require I mean each multi-frame requires 120 millisecond. So, 1 by 120 we have got 20 such frames, and there are 8 slots in each frame, and each requires 162.25 microsecond, as we have seen, and then that gives you millisecond, that gives you 270.8 kilobits per second. So, once in this way you get 270.8 kilobits per second digital data. So, this is digital data is converted into analog signal by using this GMSK technique, which is essentially a modified version of FSK. So, this generate 200 kilohertz analog signal, which is sent to the transmitter from the mobile station to the base station. So, similarly from the base station to the base station to the different mobile stations, it is same, except the frequencies will be different, these carrier frequencies will be different. So, you have got 124 channels. So, each of these channel can support 8 different users sending digital voice or digital data also possible. So, this is how the communication is performed in GSM. Now, we have seen that it combines both TDMA and FDMA. So, by combining TDMA and FDMA, it is able to send you can see 8 into 124. So, many voice communication is possible simultaneously. Of course, some of them will be used for control purposes. And there is a large amount of overhead in TDMA. We have seen that 114 bits are generated by adding extra bits for error correction, and so a very insignificant portion is data. So, overhead is very large in this GSM, and because of complex error correction, it allows reuse factor as low as 1 by 3. That means, here the reuse factor will be 1 by 3, and each cluster will be having only 3 cells. So, this is the case of GSM. Now, let us consider the interim standard 95, that is your CDMA. CDMA is quite complex in the sense the forward transmission and reverse transmission is different. Forward transmission, that is from the base station to the mobile stations. This transmission uses one type of signaling technique. On the other hand, mobile station to the base stations uses a different type of signaling techniques. Here it uses CDMA. On the other hand, from mobile station to base stations uses direct sequence spread spectrum and FDMA. So, let us very quickly have a look at how it is being done in case of your IS-95. In IS-95, as you can see, you are using 3 kilohertz voice channel, and by using digitization you are generating 9.6 kilobits per second. Then by using error coding, repeating and interleaving, you are generating 19.2 kilobits per second, and this use 19.2 kilo symbol per second, you can say. So, kilo symbols per second you are generating, and this kilo symbols per second it is being multiplied by using some by a pseudo random sequence. You can see here you have got a electronic sequence number which generates a long code generator, each of that 22 to the power 42 long 2 to the power 42 long sequence pseudo random sequence generator PRBS. So, this is a pseudo random sequence generator which generates 1.228 megacycles mega chips per second. So, out of 1 out of 64 is selected by this decimator. Decimator chooses 1 out of 64, and that is how it gets 19.2 kilo symbol per second, which is being multiplied with the that data that is coming, and to generate 19.2 kilo symbols per second. Then you are using a CDMA technique which uses a 64 by 64 table, Walsh table. You already know the Walsh chip, and for CDMA you require some kind of synchronization. Here the synchronization is provided by global positioning system through satellite. So, satellite provides the synchronization signal to the base stations, and that is how the communication, the CDMA technique is possible. And as you can see, all will be transmitting simultaneously. Here there is no serial communications, and then these are performed using QPSK. You are generating 1.228 megahertz, which uses by using FDMA you get 25 megahertz band, which is being sent to the from the to the mobile station. So, it goes to mobile station, and you have got 24 such analog channels. On the other hand, the reverse communication is completely different. As you can see, it uses a digitizer to generate 9.6 kilobits per second from the 3 kilohertz voice. Then after error coding, repeating and interleaving, you get 28.8 kilo symbols per second, and from this it selects 2 to 64 symbol modulation. Actually 6 symbols, it selects 6 symbols, and each of them is coded as 1 out of 1 to 63 different numbers. So, 1 to 63, 0 to 63 different numbers. That number, by using electronic sequence number, again you generate here long code sequence generator, that is again 2 to the power 42 bit pseudo random binary sequence, which generates 1.228 mega chips per second, and this is multiplied with this this signal coming here to generate direct sequence spread spectrum. So, here you see we do the CDMA is not being used. So, this direct sequence spread spectrum goes to QPSK to generate analog signal, and these 20 analog channels goes from the mobile stations to the base station. So, this is how the CDMA technique uses the reverse transmission is performed in IS-95 CDMA technique. So, we have discussed the 3 different approaches used in second generation. Now, let us have a look at the third generation technique. This third generation technique uses both digital data and voice communication. So, in case of your second generation, either voice or data of very low capacity can be sent, but here the objective is to send good quality on high band data of little higher rate and good quality voice. So, and the one objective is to provide universal personal communication. That means one can listen music, one can watch movie, one can access internet, all these things would be possible by using third generation technique. And it has been, I mean, there is a report that in Japan where the third generation technique has been deployed, people are not using the laptops. Instead of that, they are using these 3G cell phones to perform most of the things which are being done by using laptops. So, these are the criteria of 3G technology. So, the voice quality should be good as the public switch telephone network. The data, there are 3 different types of data rates supported, I mean to be supported. Whenever for moving at higher speed, when a car, for example, you are traveling by car or train, then the data rate can be 144 kilobits per second. On the other hand, if you are moving slowly for pedestrians, the data rate is 384 kilobits per second. On the other hand, for stationary objects, for example, sitting in a room, you can communicate at the rate of 2 megabits per second. So, that you can see high data rate is supported in 3G technology, and it is to support for data communication through both packet switch and circuit switch data services, and to provide 2 megahertz bandwidth as I mentioned, and interface to internet, so that access to internet is possible. And with this objective, ITU developed a blueprint called Internet Mobile Communication for the year 2000 and IMT 2000, and it uses 5 radio interfaces, 5 different radio interfaces. So, you can say it has got 5 different standards using 5 different radio interfaces, and all these 5 have evolved from second generation technologies. The first 2 are based on CDMA. First one is IMT-DS using direct sequence spread spectrum, and second one is multi-carrier IMT-MC using multi-carrier. The third technique is using the CDMA and TDMA, IMT-TC. Then the fourth technique is based on again TDMA, IMT-SC using single carrier, and the last one is based on FDMA, TDMA and FDMA, IMT-SC, which uses frequency time. So, these are the 5 different techniques. We are not going into the details in this in one lecture, it is not possible. So, I have just given you the goal and the overview of the third generation technique. Now, it is time to give you the review questions. First question is, what is the relationship between a base station and a mobile switching center? Second question is, what is reuse factor? Explain whether a low or a high reuse factor is better. Third question is, distinguish between soft and hard handoff. Fourth question is, what is mobility management? Fifth question is, what is AMS and in what way it differ from DAMS? Sixth question is, what is the maximum number of callers in each cell in a GSM? And here are the answers of the questions of lecture number 29. First question was, why spread spectrum technology is used in wireless LAN? As we have mentioned, spread spectrum technology is used in wireless LAN because spreading makes it difficult for unauthorized persons to make sense of the transmitted data. That means, it provides you some kind of privacy and security. Moreover, it also reduces the power density and provides redundancy. So, power density and redundancy is provided by using this spread spectrum techniques. Second question was, how hidden station problem is overcome? As we already mentioned, the hidden station problem is overcome by using a 4-way handshaking protocol known as CSMA-CA. So, by using this 4-way handshaking protocol, the collision is avoided, and also the hidden station problem and exposed station problem are overcome, which we have discussed at length in the previous lecture. Third question was, what is network allocation vector or NAV? So, when a station sends an request to send frame, which is one of the signal used in 4-way handshaking, it includes the duration of time that it needs to occupy a channel. All other stations which receive the signal create a timer called network allocation vector. So, based on this information, a timer is set and which is called network allocation vector, that shows how much time must pass before these stations are allowed to check the channel for idleness. So, this is essentially is referred to virtual carrier sensing, which we have mentioned in the last lecture. So, this network allocation vector allows implementation of virtual carrier sensing. Fifth question was, what is WEP and how is it achieved? We have seen because of broadcast type wireless communication, wireless LANs are subject to possible breaches from unwanted monitoring. To overcome this problem and to get security similar to that of wired LAN, IEEE 802.11 specifies an optional MAC layer security system known as wired equivalent privacy. It is achieved with the help of a 40-bit shared key authentication service. By default, each BSS supports up to 4 basic service set. We know that supports 4 40-bit keys that are shared by all the clients in the basic service set. So, it provides privacy without any integrity check. Fifth question was, distinguish between Piconet and Scatternet used in Bluetooth technology. Piconet is a small ad hoc network of at most 8 stations that you have seen. You can form a Piconet having a master station and a number of slaves, up to 7 slaves. Now, a Scatternet can be created this by using this as a master station, which is a slave of this Piconet of another Piconet. So, here you can have a number of slaves stations. So, this slave of this Piconet becomes the master of this Piconet. That is how the Scatternet is formed by combining several Piconets. So, with this we come to the end of today's lecture, and in the next lecture we shall discuss about another wireless communication technique over much larger area by using satellite. So, in other words, in the next class we shall discuss about satellite communication systems. Thank you.